Good morning, everyone. Welcome to AWC's webinar number 26. Today we're doing ozone for water treatment. We're joined by Jim Lauria from Mazzei. And again, I keep pronouncing that wrong, so you're going to have to correct me here, Jim.
That's all right. It's amazing.
You know, one of the fun things about going into ozone is while I don't have a lot of experience with it personally, is we can use ozone and it is integrated into a lot of parts, whether you're going with municipal, industrial, potable water, wastewater. So it's one of the ones that you can really fit just about anywhere you're going with. So if this is the first time that you're logging in, welcome. For everybody that's been with us before, welcome back. This is kind of the list that we're going through as far as webinars. If you've missed any of these, they're on our YouTube channel. You can go in there and have a look at them. Again, they're all 15 to 20 minutes. We keep them very compact, short and sweet. I keep calling them bite-sized brownies. You just need one, right? Just one at a time. So, and we're adding to this, we now have another 3 or 4 webinars that are lined up for the next couple weeks. So a little quick, short background to AWC and who we are. We've been around for 40 years. We have close to 600 plants, but that's both potable and wastewater treatment plants worldwide. We divide them into potable, of course, wastewater, and skid-mounted systems. Again, going back to ozone, nice thing about ozone is that we can tie ozone into any one of these. So whether we're going into, the potable side, adding it as a wastewater, or of course on skid-mounted systems. So with that, I'm going to bring it over to ozone for water treatment. It is what we came for. So thank you very much, Jim, for being here, and take it away.
My pleasure. So I'm going to share my screen, and let me make sure you can see that.
Can you see it?
Can you see my screen?
Can you see it?
Yes, we can.
Okay, great. So let me get in presentation mode. Okay, great. So first of all, I want to thank Alex for inviting me. Alex and I have been connected on LinkedIn, and he asked me to present. So I'm really pleased to do that for the group. I would imagine that most of the people on the call know that ozone, O3, is a highly reactive gas that's comprised of 3 oxygen atoms. And I hope that's all I'd say that you will not know. I hope there's a lot of information that I share that will be new to all of you. So a little bit of history. Back in 1839, Christian Friedrich Schonbein, he was doing some experiments in the lab, and he was doing some electrolysis, and he found out that he could create ozone by splitting the oxygen molecule and recombining it to form O3. And if you've ever been around a lightning strike or an electric motor that's arcing, you'll smell that pungent smell, and that's ozone. And the word ozone comes from the Greek ozine, to give off an odor. So just a little bit of history there. So ozone has a very high oxidation potential. And so today we're going to be talking about its use in water treatment, specifically municipal water treatment for drinking water, water reuse. It's also used in purification of bottled water, ultra pure water. Some other areas that it's used in: food and beverage applications, aquaculture, storage and transport of fresh produce, clean in place, CIP in breweries and wineries. It has some medical usage, healthcare settings, laundry, decontamination, used in some dentistry applications and medicine. And for industrial applications, mining, pulp and paper, air handling, aquariums, cooling towers, so on. Another bit of history: the first ozone for a drinking water plant was in Nice, France, back in 1906. And it wasn't really applied in water treatment in North America until the 1940s. And I'll talk a little bit about that going forward at the end of the presentation. So talking about ozone generation. So as I said, you probably know it from its formation during lightning strikes. It's basically a corona discharge. So the ozone generators, I like to think of them as a lightning strike in a controlled setting, controlled environment. And it's created with this narrow discharge gap Some of the things you can create it either with air as a feed source or pure oxygen. The gas must be dry, it must be particle free, and it must be cooled. So here's a photograph of an ozone generator in a municipal water plant, Toho Water Authority. It produces about 400 pounds per day. This particular facility is in Florida, and they do about 5 MGD, and they're using it, the ozone, to oxidize hydrogen sulfide. So why use ozone for water treatment? So you can see here, if you look at a lot of other oxidants, it's much higher oxidation potential than, say, hydrogen peroxide, chlorine, bromine, chlorine dioxide, hydrogen peroxide. So it's a good oxidant. And some of the advantages and disadvantages. So it's one of the strongest commercial oxidants, as I showed on that graph. One of the disadvantages is it can create bromate, which is a carcinogen, a disinfection byproduct. But I'll talk about how you can mitigate that in some of the ways of using ozone for water treatment. The residual is short-lived and converts to O2, which is an advantage, and it's also a disadvantage. So it's an advantage in the fact that it breaks down to O2, which in most cases is beneficial in water treatment. But because it's short-lived, it doesn't have that residual that can be used to make sure that it does its job in water distribution systems, similar to what chlorine does. And that's one of the advantages of using chlorine, because it stays around and it does its disinfection properties throughout the distribution system. Ozone adds no chemicals. It can be generated on site, so you don't have to transport chemicals to the facility. And then we're going to talk a little bit about advanced oxidation process. As you use ozone with some of the other treatment technologies, you can produce hydroxyl free radicals that can help with the breakdown of pharmaceuticals and other contaminants of emerging concern. So a couple of the ways that it's being used for water treatment: disinfection. So because it's a very strong oxidant, it destroys cellular material. So it works very well to treat against cryptosporidium and giardia. These protozoan, they have a particular benefit to themselves of being able to be resistant to chlorine. So ozone can take care of them as a disinfectant. It can destroy bacteria like Legionella and viruses. And then it also removes contaminants like cyanotoxins that are created from algal blooms. As I mentioned, pharmaceuticals that are left in wastewater, taste and odor compounds, and also is good in oxidation of iron and manganese. So we talked a little bit about disinfection byproducts. Chlorine, as you well know, creates trihalomethanes, THMs, haloacetic acids, which are also carcinogens, and also creates bromate. But again, as I said, bromate can be mitigated by some techniques that I'll discuss going forward. So here's a look at some organic color reduction. And as I said, it's good at oxidizing taste, odor, and color compounds through the addition of ozone. You can see various treatments of ozone along the way, removing those colors right down to fairly colorless. As I mentioned, ozone pairs well with other treatment technologies. So advanced oxidation processes, AOP. So ozone plus UV and ozone plus hydrogen peroxide work well together to form those hydroxyl radicals that can be really good at breaking down those long chain molecules that are involved with pharmaceutical results and also these contaminants of emerging concern. Now another combination of technologies is ozone plus biologically active filtration, BAF. And what happens there is ozone breaks down these long chain molecules into what I like to call bite-sized pieces for the biologically active filter to act upon. So the BAF has some substrate to hold microorganisms that digest these molecules, these organic molecules. And if you use ozone to break them down, they're more easily digested, and it works better in treating these waste streams. Now, ozone plus BAF is now being looked at as versus reverse osmosis. And with any type of process technology, you always have to look at what's the total life cycle costs. So what's the capital cost? What's the installation cost? What is the operating cost? And what is the disposal cost? And one of the nice things about ozone plus BAF is that you're actually destroying the contaminants. With reverse osmosis, you're concentrating them. So the contaminants are taken out of the water stream, but they're put into the brine, and then you have to dispose of the brine, and that becomes an issue of, are those contaminants going to be released into the environment at some later date? So there's several ways of putting, once you generate the ozone from the generator, you have to put it to dissolve it into the water stream. And so you've got to put it in a couple of different ways. Fine bubble diffusion has been the traditional way of dissolving the ozone into the water stream. And now more prevalent is side stream injection, and I'll talk about each of those in turn. So the fine bubble diffuser looks like this. I think many people are familiar with this. Ceramic or plastic membranes that bubble up the ozone into a basin. And so you need some kind of depth in that basin to give it time for the gas bubbles, the ozone gas bubbles, to diffuse into the water. The other way of doing it is side stream injection. So you take a 10–15% side stream using a pump. You pump it through a venturi injector. The injector creates a suction that pulls in the gas, the ozone gas, and then dissolves it, mixes it into the stream. And then that's followed by either a pipeline flash reactor or a basin nozzle manifold. So the pipeline flash reactor actually takes that ozonated side stream and injects it back into the mainstream and mixes it in with the full flow. And then the basin nozzle manifold works similar to the fine bubble diffuser, where you're using a basin, but you're getting better mixing, and you don't really need the level of in that basin to get the actual dissolution of the ozone gas. So this is a graph we looked at. We just did a thorough analysis on all the projects in North America. And as I said previously, the first use of ozone in drinking water was back in the 1940s. And so over that period of time, fine bubble diffuser was the way that they were using to dissolve the oxygen, the ozone into the water stream. And then some things changed in the mid-1990s. The ozone generators were becoming more efficient. Before that, they were typically producing 2 to 3% weight of ozone, and they were using air to produce the ozone. Around the mid-90s, the generators were becoming more capable of producing 10%, 12%, 14%. Now I think they're even up to 20% ozone concentration by weight. And they were using pure oxygen in the form of liquid oxygen, LOX, to produce it. So you can see as time's gone on that because of the changes in the way the generators are operating, the side stream injection is becoming more prevalent in fine bubble diffusers that had been in the past. So I have to talk about safety issues. As I mentioned, one of the good things about ozone is it's a strong oxidant and it destroys cellular material. And that's great when you're talking about bacteria and giardia and crypto and viruses, but it also damages lung tissue. So you really need to make sure that people are not exposed to ozone. And before if any undissolved gas is left around, you really want to treat that and capture it so that no one is exposed to it. There's certain ways of doing it. There's what's called a destruct unit in the ozone generation process, that there's a catalyst, and it basically takes that undissolved ozone and it breaks it down into benign products that can go out to the atmosphere. I covered a lot of information in a short period of time. I want to make sure that people understand that there's a really great resource around ozone. It's the International Ozone Association, the International Ozone Association, the Pan American group that I belong to. If you go to their site, they've got research papers, they've got safety videos, they've got white papers. I mean, this is a great resource for anybody that really wants to understand ozone, its benefits, its advantages, and how to use it safely. And you can contact me. There's my email address, jlauria@mazzei.net. You can connect with me. I'd love to connect on LinkedIn. That's how Alex and I got to know each other, and that's how I got to do this webinar. And also, Alex wanted me to let you know that on a regular basis, every 2 weeks, I do a podcast with my co-host, Adam Tank. What are we talking about? And we bring on some really great storytellers in the water industry. It's sponsored by Water Online. And you can go on Water Online, and we can definitely engage at that point as well. And with that, I'd be happy to take any questions.
Thank you, Jim. That was a lot of information in a short amount of time. So we're opening it up for questions. And if you take a look at the chat box, you'll see that there's already another couple questions that are coming in. So let me see if I can go through them real quick. But I'm going to ask my first one here. So here it goes. You mentioned that we're using this in a lot of different applications. How would you see it used, for example, well, let me reword that here. If we're using it in different applications, but we do have potential byproducts, is this all due to organics, like you would see in other oxidants, say chlorine injection or hypoinjection?
Well, some of it. I mean, with bromine, and one of the things I didn't mention, I appreciate you bringing that up, is that's one of the advantages of side stream injection. So if you've got bromide in the water, you can form bromate, and you can adjust chemicals to if you're using a fine bubble diffuser. But because you're taking some period of time through the dissolution of the ozone into the basin, that takes minutes. With a side stream injection, by using that venturi injection, it takes seconds. So the reaction time is much less to form that bromate. So it's an important aspect, and that's one of the ways to control it. So yeah, I mean, there's a lot of, we could go into a lot of the chemistry of how bromate forms. It would take a long time, and probably someone with a lot more chemistry background than me. But that's one of the issues. I mean, if you got bromide in the water, then there's chances you're going to form bromate unless you take specific actions to prevent it.
Okay, so here we have some more questions coming in. So how efficient is ozone used in iron precipitation versus chlorine and air diffusers?
Right. So it's all a matter of the amount of iron in the water. You always want to use the most cost-effective way. So, a lot of times we use our venturi injectors to put air in, and that's obviously air is a lot cheaper than ozone, right? So you have to just judge and make a determination how much iron you have in the water and what's the most cost-effective way to do it. And then obviously you got to also measure that with disinfection byproducts, right? If you're using chlorine, then you have a chance of forming some trihalomethanes. And so, there's a lot of ways that you have to look at. Again, it goes back to that whole idea of capital cost, operating cost, installation costs, and so on.
Okay, so next one here is, how does ozone compare versus UV-AOP, advanced oxidation?
So when you say UV-AOP, ozone alone, you don't create the hydroxyl radicals. So it depends on the type of contaminant you're trying to remove. And so if you're using UV AOP, then you're probably combining UV with something else, hydrogen peroxide, maybe ozone. So, I mean, you have to really judge. Again, it's not a cut and dry answer. It's not clear cut. You really have to do the analysis to determine all the type of water you're treating. You know, let's face it, UV has a tough time with water that's cloudy because you need to make sure you've got the transmittance. So again, you know, it's not one easy answer.
All right, another thing, thank you for that. Another question here from Monique Durand. So are there any alternatives to ozone destruction for safety?
Any alternatives? Yeah, so a couple of things. You want to get as much ozone into the water as possible. So, you know, you want as high a mass transfer efficiency as possible, 95% or greater. The more, two reasons. Number one, you want if you're producing ozone from a generator, that's costing you something in energy, in time, labor, all those things. But and then the second thing is you don't want to have that undissolved gas someplace else. So yeah, I mean, you want to get it in as that's the main thing. Get it in as most efficiently, and then deal with the residual gas, capture it, and then destroy it.
Okay, and last question that's coming in, I want to make sure I word this properly. It says, how efficient is ozone used in micropollutants, CEC removal?
Right. So I would say that alone, it can do a decent job. But if you're really looking at those long chain contaminants of emerging concern, you want to have some kind of oxidation process. You want to have it in combination with something, either with an AOP process, with UV or hydrogen peroxide, or you want to look at ozone plus biologically active filtration. So again, you know, you have to really look and determine what's the best, most cost-effective way of designing the system.
Excellent. Okay, well, if we don't have any more questions coming in, I want to thank you, Jim. I want to remind everybody that we are doing this every 2 weeks. In 2 weeks, we're going to be doing webinar number 27 on PRV. It's a little different twist. It's pressure recovery valves. So again, not really on the treatment side, but more on the energy efficiency of what we can do with our water. And of course, I've got to add this on here. We just had World Water Day on Monday. So I say let's call it Water Week. I insist it's not something that we should be celebrating once a year or once a week, but it's something that we should really focus on. Here are some of the basic questions that I'd like you to just consider. And of course, lastly, make sure that you tune in to the YouTube channel. There's a lot of information on there with some of our past webinars and anything that's future. You can subscribe and have a look at it, even put in a couple questions, and I'm sure we can go in there at an after, go in there and reply to some of them. So I'm going to leave you with our contact information. If you have any other questions, please let us know. You can get a hold of us directly. With that, thank you very much for making it. We're right on time, 24 minutes sharp. So thank you very much, and I will see you in 2 weeks. Goodbye.
Thanks, Alex.